All right, the DFCu roller pump series. You'll notice that there's a little Paraflow FMP series. We put that there because our pump is very similar to the Paraflow FMP pumps. What this means is if you happen to see applications out in the field that are using Paraflow pumps, we can supply parts for replacement parts for these. So that's very important to know. So if you're out in the field and you see a Paraflow pump running, you'll know that you'll be able to provide direct support and possibly put in one of Prominent's pumps in there. These pumps are used in industrial and municipal applications. Heavy-duty pumps, very robust pumps. Flow range ranged from 0.11 gallons per minute and that's starting off with the smallest pump. That's the DFC 30. That's the minimum flow. To 130 gallons per minute, which is the DFC 70. Obviously, we do not recommend a pump running at the full capacity. You got to take into consideration, you got to look at it as your car. You don't run your car in the red RPM 100% of the time because your car won't last long. Same thing with these pumps. So the key is to try to run them as slow as possible because the number one factor in these pumps is the hose. So we're looking to maximize that hose life. Max pressure on these roller pumps rated at 116 psi. So you can have applications in that range. Once again, it's roller technology. Our major U.S. competitors, Watson Marlow, which is the Burdell line from Watson Marlow, they use shoe pumps. They do not have roller technology. They don't believe in roller technology. Obviously, Watson Marlow is the leading supplier of hose pumps, Burdell. But I think we're taking a good chunk of their market out there with our pumps. Verter, they also use shoes only. And then obviously Paraflow. Paraflow uses the same, almost the same pumps as we do. They offer roller pumps from their smaller pumps, and they also offer shoe pumps, which we do as well, which is our DFD series. And we'll talk a little bit about the difference between rollers and shoes here in a few more slides. Roller and shoe technology. There's minimal friction between the hose and the roller. So starting operational torques are very, very low. There's no, so you basically what we're talking about is we're putting motors that are less horsepower on our roller pumps because there's very little starting torques because we're using rollers with bearings. You can see on the drawing here how the roller assembly attaches to the rotor. And we talked about those lower torques. And you can see there in the picture how the rotor is assembled. It's two rollers. There's shims that go underneath that bracket. Those shims are what we use to control the pressure. The more shims you put in underneath that roller, the more pressure you're going to achieve. Now, remember, the more shims, the more pressure, less hose life because you're putting more pressure on the hose. But that's the basic breakdown of the roller assembly and the rotor on the DFC pumps. Utilizing lower torque requirements allows for a much wider turn down. If anybody attended the webinar that Jim did last week, he did a webinar on turn down and how to figure out turn downs and all those things. This is very important in our pumps because of that wide turn down with the rollers because you have very low torque requirements. You can turn these pumps down as low as 1 hertz. So depending on the application, you can be talking about 0.5 RPM, 0.2 RPM. So it's a very good option there. The design is suitable for operating pressures up to 116 psi with the reinforced hoses that we provide on these pumps. So let's talk about rollers. We're going to compare the difference between rollers and shoes. So let's emphasize on the rollers first. They have lower operating pressures. 116 psi is the max, the rated max for those pumps. Lower operating torque. We keep emphasizing on lower operating torque because it takes very little due to the fact that you're on a roller and a bearing, and it doesn't slide like a shoe. It gently massages the hose, and thus you don't require the higher operating torque. Wide turn downs, as we spoke of before. The early leak detection. Here's the advantage of having early leak detection. The DFC pumps are dry housing pumps. There is not a liquid silicone bath as used in the shoe pumps. That liquid bath in the shoe pumps is used for two main purposes. One is for cooling. That's the number one thing that it's used for. The other is lubrication. So, with early leak detection, because we have a dry housing in the DFCs, the leak detector is mounted at the very bottom of the pump. So, in the event of hose failure, the leak detector will pick up the rupture of that hose immediately and either shut the pump down or send a signal, however it's wired in the system, to alert you of a hose failure. So that's very, very important. It's less messy than dealing with shoe pumps. One of the things that we've noticed talking to a lot of the maintenance personnel is that they like these pumps because when it's time to do maintenance, to remove the hose, they don't have to worry about cleaning up that the bath, that silicone bath that's in the shoe pumps. So all you do is remove the hose, clean it up from whatever residual you have inside, put grease on the new hose, install it, and you're back in business. Lower hose stress, obviously, because you don't have a sliding shoe, you have a roller. It, as we said before, it massages the hose instead of sliding over. That creates longer hose life because you put less stress on the hose. Remember, the number one factor in hose pumps is the hose. That is the component that makes or breaks these pumps. So now let's talk about shoes. Shoes have a higher operating pressure than the rollers. They also have higher operating torque. And the reason why is because now, since we're having a shoe instead of a roller, we need to have breakaway torque to be higher on the shoe pumps. Narrow turn downs. The shoe pumps are limited to a minimum RPM of 3 RPM. The reason for that is because if it goes below that, you have something happens called dry shoe. And what a dry shoe means is that the shoe is stuck to the hose because it does not have enough torque to break away and clear the hose. So 3 RPM is your minimum. So that's why we come down with a narrow turn down. Later leak detection. As we spoke earlier, the shoe pumps have the liquid silicone bath inside of them. That bath is filled up almost halfway up on the pump. So the leak detector is above that bath. So what happens is you won't get a notice that your hose failed until the housing is filled to the point that it reaches the leak detector. So you have later leak detection. There could be issues with that where if you have too much of that product inside of the housing built up, and if it's a very harsh chemical, you could run into the problems of it affecting gearboxes. So that's one of the things about shoe pumps that we note. Later leak detection. That's obviously, we provide shoe pumps. Watson Marlow, Verter, Paraflow, they also provide the shoe pumps as well. Higher hose stress, once again, because of the sliding shoe, you're putting more stress on the hose, and that leads to shorter hose life. So you see where the advantage is. Now, let me explain. We're not saying that shoe pumps are bad, and that's why we also carry the DFD series, which is a shoe pump. Depending on the application, if your pressures are above 116 psi, but you require a pump to pump some type of shear product or sodium hypochlorite at higher pressures, which you don't really usually see that high of a pressure, but you could, you would need a shoe pump. So we have the option of providing both technologies, which makes us very versatile compared to our competition. So let's talk about a very critical part of the DFC pump. It is the bearing housing. As you can see on the bearing housing here, this is the bearing housing. There's a shaft right here. That shaft sits inside of the bearing housing. And the gearbox is attached, the gearbox shaft is attached to the bearing housing shaft. What that does is it provides support and does not allow the rotor to put stress on the gearbox shaft. A lot of our competition have their rotors directly mounted to the gearbox shaft. So what that does is it puts a lot more stress on that shaft. And what we've seen in the past is customers end up having gearboxes fail on them quicker because of the extra load on the gearbox shaft. So our technology, using this bearing housing, provides that so there's no weight on the gearbox shaft at all. And you are getting your gearbox, which is a very pricey component, will end up having a longer full life on it. So it's simple, as you can see, very simple product, only 6 components, and it's very heavy duty. So a great advantage, and something that we make sure to point out in our presentations. So we talk about how to pick the correct pump. Here are the main factors. All right. Number one, we need to find out what material is being pumped, because we offer 2 types of pump housings. We offer the standard pump housing, which is colored orange, and then we also offer the halar-coated pump housing, which is used for harsh chemicals such as caustics or sodium hypochlorite. So depending on what you're pumping, if you're pumping maybe let's say lime or sludge, you're going to want to stick with your basic pump housing. There is an upcharge for choosing the halar. Flows, very important to know what your flows for the application is. We want to make sure that we're fitting the correct pump to the right application according to flows. System discharge pressure, not the pump max pressure. When you're out there looking at applications, do not go by what the pump that is installed, what the max pressure is of that pump. Go by what the customer's max pressure of the system is, because he may have a pump that's rated for 200 psi, 230 psi, but his system only requires 30 psi. That's where we want to put that DFC pump in to have a better hose life and better operation than those shoe pumps. Temperatures, 175 degrees F max on the DFCs. That's where we stay. We do offer EPDM, which can go a little higher than 175, covers right around 215 F. But what we try to do is we just put all the hoses and say 175 max on all of them, just to keep it standard. Viscosity, very important when we're talking about hose pumps. Obviously, one of the advantages of hose pumps is that we can handle highly viscous products, 5,000, 10,000 centipoise. In cases like that, we may have to make pick a larger pump instead of the size that it should be. By picking a larger pump, we can run the pump even slower. With highly viscous products, the key is to run them as slow as possible and gently feed them through the hose so there's no hose cavitation. All right? So, very important to know what the viscosity of the product is. The other factor is duty cycles, whether it's intermittent or continuous. If we have a very intermittent application, say the customer's only running the pump 1 hour a day, you know what? We could probably undersize the pump, make it run a little faster, because we know it's not going to be ran as much. And in the long run, it'll save the customer a little bit of money, and it makes us look good. We're providing the right product. So we talk max continuous speeds. Very important to know. All right, max continuous speeds when we're talking with pressure. Since our hoses and our pumps are rated to 116 psi, we can provide them in natural rubber, EPDM, Buna-N. We also have the option to provide them in Hypalon. All these hoses are kept in stock here in Pittsburgh. The Hypalon hoses have a little bit more of an upcharge because they're a little more expensive to get. But we can provide these for different types of hoses depending on your application. So how do we go about pressures and RPMs? Here's the basics. At 75 RPM, you don't want at 30 psi, 75 RPM should be right around your max. At 60 psi, 50 RPM. At 116 psi, 30 RPM. Like we talked before, the more pressure, the more you're putting stress on the hose. For gearboxes, the DFC 30s through the 50s used Nord gearboxes. We've come to an agreement with Nord. They've been a great provider for us for probably, I'd say, 80% of all our pumps. 80 to 85% of all our pumps are using Nord gearboxes. And Nord is providing great lead times for us, which has actually improved our lead time to our customers, which in turn makes our customers happy, and it makes you and it makes Prominent look good. The DFC 60s and 70s use Bonfiglioli planetary gearboxes. These have a little bit longer lead time than Nord's, but they still obviously work very well with what we're using. The 60s and the 70s, there's not that many applications that we see out there. We do get them from time to time. The majority that we see are 50s and under. And then the last thing is gearbox frame sizes will change with each pump and requirements. Something that Jim brought up in the last webinar is before we took over the line of before I came on board here for Prominent, we were using 56C frame sizes on the 30s and 40s. We've changed that to start out at a minimum of 143 TC. Okay, and then depending on the size of the gearbox and the size of the pump, then the frame size will increase as it goes on. DFC 30s through 50s gearboxes range from 9 RPM to 82 RPM. DFC 60s and 70s gearboxes range from 12 RPM to 71 RPM. Pumps will not be sold without gearboxes, but can be provided without motors. Yes, the reason why we do that is mainly for mounting purposes. We can't just sell a housing and call it a pump. We can't check it to make sure that it works correctly. So we have to, the minimum we can sell as a pump is the casing with the gearbox installed. Standard motors for the DFC pumps are provided from 1 horsepower all the way up to 10 horsepower and can be offered as follows. 230, 460 inverter duty motors. These are mainly provided by WEG. And the reason why we went with WEG is because the motors are 20-to-1 constant torque. But the moment you're using a variable speed, they can turn down all the way to 1001. We also provide the explosion-proof motors at TFC with the same turndowns. All right, once again, pumps can be provided without motors. It will include the pump head with hose and rollers, gearbox with a NEMA face input. DFC pump connections. These are the 3 types of flange connections that we offer for our DFC pumps. We offer the stainless steel, which is a standard, that's the standard flange that we provide. We can also provide them in PVDF or PVC. Both of them carry an extra charge on them. Flange sizes range from 1 1/4 on the DFC 30 all the way up to 3 inches on the DFC 70. And all those different flange materials are provided. We can provide the pumps with or without leak detection. That is an option for you. You can decide to have leak detection or you can leave it without. I always recommend to use leak detection. The reason why is because you may have a $7,000, $8,000, $10,000 pump and your leak detector is only $250. So you do the math. Why not spend an extra $200, $250 to protect your $10,000 pump? It's worth it. Leak detectors are mounted on the lower aft end of the pump casing and must be wired to a VFD or a relay kit for power. Basically what this will do, if it's mounted to the VFD, if it's wired to the VFD, the VFD can be wired to shut the pump down. If it's wired to a relay kit for power, it can be sent in for an alarm to let you know that you have had a hose failure. VFD controls. Pumps can be provided with or without VFDs. We can't supply the VFDs. You can, if the customer decides that they want to use their own VFD because they already have one there, they can use that also as well. What we provide is 2 types of VFDs. We provide the basic and the advanced. And as you see there, the basic VFDs, we can provide it in 115 or 460. The 115 is only provided on the 30s and 40s. Anything above the 40s, we switch immediately to the 460. The advanced, the same way. 115 for the 30s and 40s, and the advanced on the 460 on up. And you can see the difference on the turndowns. The basic VFD has a 60-to-1 turndown, and the advanced VFD has a 100-to-1 turndown. And you can see basic VFDs are mainly used on industrial applications, advanced VFDs for municipals. All pumps, all DFC pumps have the option to be provided as a standard or chemical version pumps, as we talked about previously. The standard pumps are used with non-harsh products, like we talked about, lime, slurry, sludge. These pumps have a cast iron pump casing. These are colored orange. The chemical version, which is a black pump, these are covered in Halar coating and protects the pump for harsh chemicals such as sodium hypochlorite, acids, things like that. Here's this is provided online. The DFC series, it shows you a brief, quick curve on them. What the hoses are provided and connections. That's all provided there online. All right, and that's the end of it. What I'm going to do next is I'm just going to go quickly to the eQuote system. And I'm going to walk you through sizing the selection of the DFCs. So we'll just do one pump. We'll do the DFC 30. So when you click on the pump, you see you have all the selections, all the of the DFC pumps. So we'll start with a 30. Our speeds And you can do, you know, if you wanted to, we have a chart for what the RPM equals to flow, but you can actually do your math if you wanted to. It's very simple. Motor type, you can choose no motor. The customer can provide their own motor, or choose the motor that we provide here, which is what, like we talked about in the presentation, the 230 or the explosion-proof 230 inverter duty for both of them. Oh, excuse me. Here are the hoses, natural rubber, and I'll show you the difference. There's no cost, as you saw on the natural rubber, but the moment you choose Hypalon, there's a upcharge on the Hypalon because it's a harder material to obtain. These hoses are based on the application. Obviously, you're not going to want to put a natural rubber hose on a bleach application. So you need to know what materials are compatible with the operation. If you don't know, please contact us. Here's your flange options. Stainless steel is the standard. As you can see, there's an upcharge for PVC, and there's an upcharge for PVDF, depending on what you need. The base plates are painted steel. That's a standard option. Here's your leak detection. You can use it with drive, or you can use it with the relay kit. The relay kit has a little bit more of an upcharge because we're supplying the relay kit for it. And that's all you're paying, $205 for a VFD. All right, orientation. Oh, sorry, leak detector. Orientation. There's 4 ways that you can mount this pump. The standard way we build these pumps is always right facing. You can choose to have this pump down, left, up, or right. All hose pump manufacturers provide right facing as their standard. VFD, as you can see, you have the options there. The special versions, what we talked about, if you're using the standard pump or the chemical version pump. There's an upcharge for the chemical version, and then standard pricing, no upcharge for that. And then your discharge pressure. And then you'll see down here, you get your ident code right there, and then you can put that in your toolbox, your toolbar, so you can put it on a quote. Okay, so that's the basics of it. As you can see, these pumps are ready to go. Uploaded an e-quote. Please, if you have any questions, do not hesitate to give us a call. If you're not sure about what you're doing with as far as how to quote it, please contact us. We will gladly walk you through it or provide you the quote ourselves. All right. Thank you so much for your time today.
Yes, thank you, everyone. We'll now address some questions. I wanted to point out when Raphael mentioned the connectors right facing, if you look at the picture right here on the quote program, that is what is meant by right facing. So as you're facing the pump housing, those connectors are on the right. You can do it left, up, down, whichever way you want. Kind of the standard rule of thumb is out to the right. So that's what's meant by that. If you have further questions, again, please use the questions section on the GoToWebinar toolbar, and we will try to address those for everyone. One other question I wanted to ask Raphael, there was something I thought was special about the connectors for the DFC pump. It's not the
they're not MPT connections.
Right. But I mean, as it holds the hose inside there, it's like it's very well sealed. It's a compression type.
Yes, there's a ring that wraps around on the back side of the connection inside the pump, and that ring holds the connection to the pump to the hose. There's no slippage there.
Okay, great. So we do have one question online. What is the input and output of the VFD single phase was chosen for a 3-phase motor?
Very good question. Here's what happens. Obviously, as you saw, the motors are all 230 motors, but we have the 115 VFD. What happens is that power is converted. That the VFD has a 115 plug to a wall, so you can put it into a wall socket, and then it just converts from 230 to 115.
So it builds that extra phase into the signal going to the motor. So the motor is a 3-phase motor, but single phase into the VFD, and the VFD controls the motor. So that was a good question, good catch there. Glad you saw that, so we could point it out to everyone. As we mentioned, also as Raphael mentioned, as we're waiting for some other questions, we talked about turn down in this presentation, and also we have a presentation that we've done in the past on changing the hoses. So those are all very applicable for this C pump as well. And those are available if you go to prominent.us and search for video in the search bar at the top. You'll find all the webinars we've done in the past. And we've done some on choosing the B series as well. So at least 3 other webinars that we've done that can help you with what we've covered today as well. We have another question online here. Will you have any non-metallic roller selections in the future? How about the rotor also?
Okay, good question, Mark. Here's what right now the DFC 50 is supplied with a nylon roller, which actually we have gotten very good results on that. We are in the works of in the future to standardize all those rollers to nylon from the 30s over to the 70s, but that's going to take some time. As far as the rotor, no, the rotor is going to remain cast iron because cast iron is pretty rugged. Even if you get a little bit of sodium hypochlorite, yes, it may tinge, it may change a little bit of color, but it's not going to affect it where it's going to break it down completely. The other thing with that is that because we have early leak detection, and that leak detector is put at the bottom of the hose, of the pump, that will not affect the rotor because it will not flood it. So the housing will not be flooded due to early leak detection.
Very good question, Mark. Thank you for that. If anyone else has questions, please continue to add them into the questions section. One other thing to mention is if you have topics for us to cover for future webinars, we would appreciate you send those over. As we cover more and more of those, it becomes harder and harder to come up with topics. So we need to know what you would like to see, and we'll work those into the schedules. So please don't hesitate. Feel free to pass those on. As we mentioned, these can be very complementary to some of the other products that we've offered here recently. The polymer units, whether it's a Promix or a Tomal unit, these work very well together with those. So please don't hesitate. If there are any questions, please don't hesitate to ask Raphael. One of the things to mention also, the quote program, when you pick that out in the quote program, it's going to size the motor properly for you. It's going to pull in the right horsepower motor. And all of the things, it kind of narrows it down so you can't get it wrong almost. There are very few selections where you really have an option that won't work with a previous selection. So if you work from the top going down, it will fill in so that those mistakes almost can't be made for you.
Let me piggyback on that what Jim says. One of the things that I provide for our customers when I do the quotes is, as a added bonus, I put in on the quote body what the actual horsepower of the motor and what the connection sizes will be. So you won't have any questions on what that will be. If you are building the quote yourself, you're not going to get that. So if you need to find out what the horsepower of that motor is going to be, and obviously the quote program is not going to give it to you, please send me an email, call me, and I'll be able to gladly assist you on it.
Raphael mentioned the roller. It saves you power. That power, more and more people want to hear about green options, savings. That means money savings to them. This will do that over a shoe type pump. So, that's a very good approach for it. The B's and C's, DFB and DFCs, are now both in the quote program for you to do. If you need specific gearboxes, maybe to meet a specification or a special motor to meet a specification, let us know, let Raphael know, and he can work with you to kind of build that as a custom item or work with engineering to help do that as well. But those B's and C's, for the most part, are available in the quote program for you to do yourself. And that's a huge benefit. You can provide that quote. That's probably, as far as hose pumps go, the B's and C's are going to cover at least 90% of the applications out there. So, please take advantage of those. Let us know what you need if there are any accessories. We do have very specific pulsation dampeners that we have available to us that are very unique and very specifiable. So if that's an angle that you're taking, please let us know about that. It's something that might be a huge benefit.